Welcome everyone, my name is Fiona and this is a presentation I made for getting my master's degree, and it's about what I did in my master's thesis. I will start with a little introduction. In 2020, around 3.1 billion people played video games worldwide. That is 40% of the world population. And on the other side, 15% of the world population has some form of disability. That is over 1 billion people. So it's not surprising that these sums overlap, and there are more and more people who want to play video games but are excluded from it because of the game not being accessible and having barriers they can't overcome. So the topic of my thesis was called Accessible Hands-Free Input Methods for a Serious VR Game. And basically it's about barriers in games, especially VR games, and I researched how well a VR game can be controlled without using the hands with different methods. And for this I worked on 2 programs and I tested them with users. I'm going to start with relevant topics. So why is the topic important and what background information should you have? Then there's guidelines, meaning which guidelines are there for VR and games. I will show you my implementation, what I did and how I did it, and the evaluation. So how did I test this and what was the result? And at the end, I will summarize this and draw a conclusion. Now, there were several topics involved in my thesis, which are important to understand the context of the word. And I made a graphic for this. So the 3 big points are accessible computer games, VR, and serious games. And I will get to that in a moment. This graphic will accompany us through the presentation as I will talk about these honeycombs one after another. I'm starting with the background knowledge, which is basically the theoretical part of my thesis, and I try to keep it short. I start with serious games. So serious games are real games, but they are not only about fun, but also want to teach something. And there are different terms for this. I use serious games as an umbrella term for all games with a serious background. And I found several studies that show that learning through games help to make learning easier because, of course, it's more fun and you're more motivated to stick with it. And in the end, you learn more by learning with games. Serious games are relevant for this work for 2 reasons. On the one hand, the implementation I will show you in a bit is based on a serious game called BioVR. And on the other hand, there are legal regulations that games used in education have to be accessible. Next up are accessible games, and there are 2 sides I have to mention. One are the problems with games, and the other are the relevance and possibilities of games for people with disabilities. And I will start with the problems. So to play games, you usually need different skills. And this is broken down into cognitive skills, being able to react to the game. The output, meaning to see or hear what is happening in the game, and the input. And most of the time that means you have to be able to use a controller, and that is what my work focuses on. Additionally, the selection of accessible games is very limited. Accessibility features are usually implemented for research purposes, and the games are only available as prototypes. So mainstream games often don't really care about being accessible, and that is attributed to the fact that game studios and developers either think it's not worth it or just don't think about accessibility. Another point that will be discussed later is in more detail is the lack of guidelines. And as already mentioned, disabilities are very individual and everyone can benefit from different features. So it's very difficult to find a good balance between making a game accessible and making a game still fun to play. So just now, we actually saw why accessibility is important in games, because the amount of people who benefit from accessible games is often underestimated by game developers and studios. And of course, games are meant to be fun, but they can also be so much more. They can be a distraction from everyday life. They can connect people. You can meet in online communities, play together and be with friends. Some people can do things that they would otherwise be not able to do in the real world. They can learn in a safe environment. Then there are the legal regulations that I already mentioned, and ultimately, accessible games are universal. So not only people with disabilities can benefit from accessibility features. That means, as an example, think about like you broke your arm and you cannot hold a controller, or your headphones are broken and you need subtitles. And these are called situational disabilities, so barriers that occur in everyday situations. On to the next topic, VR. VR is not really a new thing. The technology has been around for some time now. But let's be honest, so far it has a lot of weaknesses. And game manufacturers were the first to hop on the VR train, which is why most VR applications are games right now. And the opportunities and the problems I mentioned from accessible games also apply here, but there are new ones added. As I said, I focused on the input methods, and as with normal games, you have to be able to make some form of input to play a VR game. And the different manufacturers all have their own controllers right now. Then there's mid-air gestures, maybe hand tracking. Sometimes you have to stand or crouch or turn your head to look around. And for this, you need full control and strength of so many body parts, like arms, fingers, head, neck, maybe even legs. And very often there's no alternative for this. On the other hand, VR also offers new input methods that are not possible with normal games, and I will show you some in a bit. And also, there's the change to experience, the chance to experience a lot more things that otherwise might not be possible for some people, like driving a car or riding a horse. And this is where the circle closes, because not only normal games, but also VR games are more and more used as serious games in schools, at universities, in museums. And it's proven that things you do in VR help to learn, and above all, you can remember them better because you did not only see them, but you experienced them. So that was the theoretical part. Now there's a few more topics that that have to do with my implementation, and I will go over these now one by one. So I will start with the guidelines, BioVR, the input methods, and the menus. As I said, I'll start with the guidelines. And to be clear, we are talking not about like normal guidelines, but accessibility guidelines. Why is this topic important in this context? There are many accessibility guidelines for web applications that developers can follow and just use it as a checklist and improve their websites. And as I said, there are legal regulations that are also in the form of guidelines. So guidelines play a role here. During my research, I kept coming across the statement that the lack of accessibility and the lack of guidelines have something to do with each other. And we will see in a moment that there aren't many guidelines for games and even less specifically for VR. And this circumstance is blamed for the fact that accessibility is an issue that is not being considered well enough now. So this is going to be an overview of the guidelines that I have found, and the fact that they fit in these tiny boxes shows how few there are. I will start with the EN 301549. It's a European standard and it includes all forms of technology. It's the relevant work for accessibility. And the problem with the standard is that because it applies to every kind of technology, so like ticket machines, it's formulated in a very complex way. For the game guidelines, I don't want to go into detail about these, I'm just going to name them. So there's a white paper from the International Game Developers Association Game Accessibility Special Interest Group, and they also have a top 10 of accessibility rules on their website. And then there's Media LT, which is a Norwegian company, and another document is includification, and there's the accessible player experience and the Xbox accessibility guidelines. And the last ones are the most important ones, game accessibility guidelines. I will link these so you can find them in the presentation. For the VR guidelines, there are two of them that I found. That's the XR accessibility user requirements and the virtual reality checks from Oculus. So what did I do with this knowledge? I compared and filtered all these guidelines so that in the end, those that are relevant for VR games remained. The whole thing looks like this. This is only the first page out of 7, and I sorted the guidelines by topic, and then I marked which rule is present in which existing set. And what I learned from that is that none of the guidelines are a complete set. So there's some rules in one set and they are missing in another. But most of the rules are included in the European standard or in the game accessibility guidelines. But for VR, I found that only the game accessibility guidelines and the Xbox accessibility guidelines include some rules about VR. And finally, there are also some rules missing in the European standard, what I did not expect. Yeah, and I used this list as the basic for my implementation. And I will talk about that now. So for my thesis, I worked on 2 programs, a demo and an existing game. And I don't want to talk about the technology so much. The only important thing is that both programs were developed with the Unity game engine for the Oculus Go, which is a standalone VR headset and comes with 1 controller. So first I would like to introduce the game I worked on, and it was used as a kind of proof of concept for this work, and it's still in development. It was developed by Manuel Fankenel, and I only adapted it to my needs, so I changed the game to be playable in VR without hands, but I tried to change it as little as possible to keep the gameplay the same. This is what the game looks like in the desktop version. It was made in cooperation with the microbiologist from the University of Heidelberg, and the goal was to make a game that is completely biologically correct but still fun. It's about cancer cells, so in the middle you see the cancer cell you start with, and the player tries to divide this one cancer cell at the beginning, and to make it stronger and mutate it to win. So you are the bad guy here. As I said, beside the visual aspect, the input is the biggest barrier in VR games. Of course, there are many other barriers in BioVR, but the input was examined in my work as an example. And I will now first introduce the methods that I have implemented, and then I show you how it looked in the game. So I differentiated between two groups of methods, and the first group is called FOKUS methods. This is the way a user focuses on a game element or a button. So for example, if you hover over a button with your computer mouse and it changes color, then you focused it. And the other group is the activation method, and this is how the element that is currently in focus is selected or activated. In the mouse example, it would be if you click the button, then you activated the button. Yeah, and the separation was useful for testing because I could test different combinations of methods. I will first introduce the focus methods, and I will partly show how they work with the help of the demo program. So we have head tracking, which is the mapping of a cursor to the head's movement. So you can move the cursor around by moving your head. And we will see that in a moment. The second method is scanning. So each element is focused one after another. And the transition is made either by a user with a button, which I call button-based scanning, or by a timer that runs automatically named time-based scanning. And we will see that later. And then there's the head movements, which works the same way as the scanning, but the transition is triggered if the user moves the head in a certain angle. And I show you how it works because we won't see it in the game later. So this is a video. I'm going to start it. So I'm moving my head down, and then I hit the angle, and then the elements are selected one after another. Yeah, the next one is eye tracking, for which an eye tracker was used, and it was built into the Oculus Go. So it, I think you know how it looks. So you have this little cursor, and it moves where your eyes are looking. And finally, I also had a standard voice control for the game. Then there were three ways in which an element can be activated. There was dwelling, which is a timer where the user just has to dwell on an object for a certain time. You normally see it with these circles that show you the time you have to wait. Then there was a button, just a normal hardware button, but instead of something for the hands, I used this page turner pedal for musicians, so the users were able to press the button by stepping on it and not using the hand. And it was blinking, which was possible to recognize with the eye tracker that I had already built in for the eye tracking. Now there's one last relevant topic. When you start a game, you normally have a menu. When you go into the settings, there's a menu. You often have skill trees that look like menus, and every time you're making a decision, it's mostly realized through menus. So menus are important for games, and they are also a good and easy example to try out these methods I just introduced. I also found studies that investigated what influence a menu has on the input methods and vice versa. And it was also my goal to see how the menus and the input methods play together. I will demonstrate the menus again using the demo program. And I had 3 types. So there's a simple list menu, a tile menu that we mostly know from mobile devices, and the pie menu. And in the studies I found the pie menu was always faster than a list because of the shorter distances. So it does make a difference. This is a video, so I will show you how the whole thing looks in the game while I try to explain what you see. And I will stop the video and explain. So this is the game board. There are the cells, and what you're seeing now is the head tracking with dwelling. So the head is moved, the cursor moves to an element, and then you see this blue circle that shows how long you have to focus the element. And the cell was just selected and then divided. What you see now is the scanning, which is button-based in this case. So you can see at the top of the screen that I show which hardware button on the keyboard or on the foot panel is pressed. And it's also realized with dwelling, but here the circle makes no sense, so it's shown with the color of the button, how long you have to dwell on it. So this is new. This is so-called point scanning, and this was necessary because it's not feasible to iterate over all the cells. So the user can position these 2 lines, the horizontal and the vertical one, and the cell where they meet is selected. So this is the position of the first line. Then there's a menu to control these lines, so you can select which one you're moving right now, and the point where they meet is selected. So here you can see the time-based scanning. That means the elements are selected one by another without the user having to do anything. And it's activated by blinks. So of course you don't see the blinks, but they are shown in this little control panel. So this was a blink, and then the screen zooms in. This one is eye tracking, so you can see this little yellow circle. This is where the eyes are looking. And you will also notice that I don't really have to move the head just a bit, and I can reach all the elements in the menu. And this is the voice control, which is also realized with the point scanning. And the difference here is that all the cells have a number and a letter to position the lines. Yeah, that was the game. We are getting there. This is the validation and the results. So all topics are yellow now because all the topics I talked about were relevant for the validation. But of course, I only actively tested the input methods and the menus. I did 2 different studies. One was a small pre-study and the study with the game BioVR. And I did the pre-study with the demo program that you saw earlier. And it was useful for different things, but above all, I was able to implement the methods in a small context and to test whether the methods can be used by people at all before putting them in the real game. And the main study was done with the game BioVR and was meant to show how the methods can be used in a specific game and how users perceive them. So for the pre-study, I did a within-group design study. That means all users have tested all methods, and I have had 5 people who were simply allowed to test the program, the demo. So it included a settings page where you could change the method and the values, and the users could just try different combinations as they wanted and tell me what they think about them. And I wrote down all the comments, and I also asked them 2 questions for each method. And I will not show you all my results, but only the important ones, which are the answers to these 2 questions. And the question were, is this method comfortable for you and do you feel efficient using it? So the head tracking was exceptionally good with a rating 5 out of 5 for both questions for all 5 participants. And the head movements were very bad and very uncomfortable for most of the people, so no one really liked it. And the other methods were somewhere in the middle. So the result of the pre-study was that I excluded the head movements from the further study. On to the main study. I also did an exploratory study here, which means I didn't measure anything like time or errors. And I had 12 people to play the game. And since I had to keep the numbers as low as possible because of coronavirus, I did a mixture of a within and between group design. So that means each of the participants played the game 3 times, and the FOKUS method remained the same while the activation method and the menu types were changed. So after each method, the participants filled out a questionnaire, and I also included the comments they gave me again in the evaluation. I then evaluated these results in different ways, and I will only show the most important ones because they all kind of come down to the same result. So I will start with the FOKUS methods, and all the methods were rated from 1 to 5. And we have to be very careful in interpreting these numbers, as only 3 people tested each of these methods because of the design of the study. So the results kind of confirm the one from the pre-study that the head tracking is preferred with the rating of 5 from all participants. And it's followed by the eye tracking, which is similarly good, and all the other methods are usable in general, but the ratings are somewhere between 3.67 and 3. So they are very mediocre. For the activation methods, I also used a standardized questionnaire called a UAQ, which evaluates the usability on the basis of word pairs. And I have listed the most prominent for each method. So what we see is that pressing a button was rated very good with 4.58, and it's also the easiest, and it's very efficient and supportive, but also kind of boring because it's so usual. Then the dwelling and blinking are rated with 3.78 and 3.67, and they are more exciting and interesting. But the problem with them both is that they were perceived as inefficient and obstructive. And the blinking even got a rating that it's complicated and unpleasant. So for the menus, again, I evaluated them in different ways, but all of them kind of tell me the same thing, which is nothing. So the ratings of all three methods are between 4.08 and 4.33. So either the results were all very similar, like here, or they contradicted each other. So I was not able to draw a real conclusion from the menu types. So this is a conclusion. What have we learned about guidelines? There are very few guidelines and tools, especially for games, and the few there are don't really care about VR, and none of them are a complete set. The European standard is super difficult to read, and there are no examples. And it would be nice to have some tools for supporting making games more accessible. For the implementation, all planned methods could be implemented and all features in the game could be used. But the thesis shows how much change and effort is necessary to make an existing game more accessible. And this really depends on the method, what I have tried to clarify with these errors. So that means hand tracking is very simple to implement. Head movements and eye tracking are kind of okay-ish, and the scanning and voice control were a lot of work because of the point scanning I had to implement. So it's not really surprising that so few games are adapted to be more accessible, because it's a lot of work and a lot of changes necessary. So this might look it's again about the methods, and it looks like a repetition, but here I summarized all the results from the pre-study and the game that I have. And I also have to emphasize again that the order I show here is only based on my results and might also be different from person to person, because I only tested these with people who can use all of the methods just fine. So all focus methods can be used to focus things in VR, and there's a clear preference for the head tracking. The eye tracking is just as good, but it can be a bit exhausting. The scanning and voice control are rather mediocre, which may be due to the point scanning, which was a bit annoying. And as mentioned, the head movements are completely uncomfortable and unsuitable. So for the activation methods, a button press is preferred as activation methods, but the dwelling should always be offered as an alternative, because you don't need to press the hardware button, obviously. Yeah, and the blink is not that suitable unless there's already a way of using eye tracking. And blinking does not really improve anything compared to dwelling. If you can use blinking, you can also use the dwelling. So the conclusion for the menus is not a good conclusion, because the results were so mixed. But if you could see all the results together, like me, then there's a really tiny slight tendency toward the tile menu, because it's compact and it's easy to use, especially with the eye tracking, because you can reach all the buttons just fine. In conclusion, the methods have little influence on which menu type is suitable, and vice versa. And that's me seeing the results. So this is the last slide. Of course, I've only dealt with one form of barrier here, and others would be just as interesting for a similar kind of study. For the guidelines, again, I created a good overview, I think, and the guidelines that already exist should be expanded with VR, and especially the European standard needs an understandable version. For the implementation, overall, I hope that the results of the study in my work can help people in the future to decide which input methods are offered in their games. Yeah, for the future, for other studies, maybe you would have to use different VR glasses, because the Oculus Go has already been replaced by the Oculus Quest, which might offer new possibilities for other input methods. And of course, the user tests can only serve as an example here. And for further tests, you would need much more people for testing. And with this, I think I have talked enough, and I can only say thank you for listening, and you can contact me if you have any questions.